Okay students, the present topic is equivalence class. Again this is a little bit difficult topic. Students become highly tension by listening equivalence class. If you understand one concept clearly, then this becomes very easy. Let us start equivalence class. And you know my style of teaching, I will not go to the definition directly. First I will explain you the things with help of some examples, some illustrations, then I will go to the definition. Okay, so to understand equivalence class, let us consider a set A, non-empty set A. Okay, the elements present in set A are represented by small a. Small a belongs to capital A, means capital A is a set whose elements are represented by small a, and let R is an equivalence relation on set A. Okay, to understand equivalence class, first remember these three things. This is a set. The elements of set A is represented by small a. R is an equivalent relation on set A. Let the elements of set A is represented by A1, A2, A3, dot, dot, dot. In generally they are represented by small a. In set A, elements present are A1, A2, A3. Every element of set A will possess an equivalence class. बुझो पिला माने set A अच्छी तार एलिमेंट गुडा को स्मॉल a रे रिप्रेजेंट कली. लेट एलिमेंट गुडा को A1, A2, A3 आर गोटे इक्विवेलेंस रिलेशन अच्छी ऑन सेट ए. तो कौन कहूची सेट ए रो एवरी एलिमेंट रो इक्विवेलेंस क्लास पॉसिबल एग्जिस्ट करिवो. मींस A1 रो इक्विवेलेंस क्लास फाइंड करि परबी, A2 रो इक्विवेलेंस क्लास फाइंड करि परबी, A3 रो इक्विवेलेंस क्लास फाइंड करि परबी. A1 रो इक्विवेलेंस क्लास इज रिप्रेजेंटेड बाय दिस सिंबल. Similarly A2 equivalence class is represented by this symbol. In generally A equivalence class is represented by this symbol. So look at again I am repeating set A containing elements A1, A2, A3. Generally the elements are represented by small a. R is an equivalent relation on set A. Now every element of set A will possess an equivalence class for this relation. If relation changes, then A1 equivalence class will also change. Okay, A1 say A1 equivalence class change hijibo if relation change. Obviously A1 equivalence class, A2 equivalence class, A3 equivalence class different भी ही पारे, same भी ही पारे, but A1 equivalence class भी exist करूची, A2 equivalence class भी exist करूची, A equivalence class भी exist करूची. So before going to definition, this much knowledge or conclusion is important. गोटे set थिबो, गोटे relation देई थिबो, सेही relation पाई set भितर थिबा every element रो equivalent class हमें find करी पारिबा. Now come to what is equivalent class. Let हमें A1 रो equivalent class find करूचे. So A1 रो equivalent class is equal to a set which contain elements. This is a set which contain elements. What are those elements? These are the elements of set A which maintain this relation with A1. A1 रो equivalence class माने कौन? set A रो जो एलिमेंट A1 सहित this relation टा maintain करी परिबे, that is called equivalence class for A1. तो set A रो जो element can develop or can maintain the relation with A1, that is equivalence class. So relation change कर देले equivalent class में change हिजबो ना नहीं. Okay, so कौन बुझला पिला माने equivalence class of A is equal to a set containing elements X such that x related to a जार इक्विवेलेंस क्लास हमें बाहर करछे ता सहित x टा ए रिलेशन को मेंटेन करथबो एंड x belongs to set A x टा दिस सेट भितरे मेन सेट भितरे प्रेजेंट थिबो सो फाइनली बुझी दूची ए रो इक्विवेलेंस क्लास माने सही एलिमेंट गुडा को जो माने ए सहित रिलेशन टा मेंटेन करिवे एंड मेन सेट कैपिटल ए रे प्रेजेंट थिबे सो मैथमेटिकली इक्विवेलेंस क्लास ऑफ ए इज अ सेट containing elements x such that x related to a and x belongs to a. Okay, now let us take an example so that you can understand of finding equivalence class. Okay, question. So let us consider a relation a congruent to b mod 3 on set of integers. This is the relation a congruent to b mod 3 on integer set. Okay, in this relation let us find equivalence class of 2. This represents equivalence class of 2. Here if I will write 3, this represents equivalent class of 2 for this relation. Here writing 3 indicates the relation a congruent to b mod 3 and we want to find equivalence class of 2 for this relation is how much we want to find equivalence class of 2 for this relation. The relation is a congruent to be mod 3. So what we have to do? Kon kariba? Now we have to find those elements present in Z and maintain this relation with 2. माने पकाओ those elements present in set A which maintain the relation with small a equivalence class find कला बेले कौन कोई थी set A रो सही एलिमेंट जो माने स्मॉल a सहित रिलेशन टा मेंटेन करि परिबे सो नाउ कोन करिवि 2 रो इक्विवेलेंस क्लास फाइंड करिवि माने कोन करिवि सही इंटीजर गुडा को फाइंड करिवि जो माने 2 सहित दिस रिलेशन टा मेंटेन करि परिबे ओके सो लेट ताकु म x नउची सो x रिलेटेड टू 2 mod 3 x congruent to mod 3 implies x कोन नली इंटीजर सेट रो सही एलिमेंट गुडा को माने जो इंटीजर गुडा को 2 सहित दिस रिलेशन डेवलप करि परिबे सो आई एम राइटिंग x congruent to mod 3 this implies I know x minus 2 is divisible by 3 that is x minus 2 is equal to 3k where k belongs to integer set. Okay, this implies x is equal to 2 plus 3k. So what we can put at place of k? We can put 0 plus or minus 1 plus or minus 2 etc. we can put. So if k is equal to 0 then x is equal to coming 2. If k is equal to 1 x is equal to coming 5. If k is equal to 2 x is equal to coming 8. Now if k is equal to minus 1 x is equal to coming minus 1. If k is equal to minus 2 x is equal to coming minus 6 plus 2 is equal to minus 4. So look at we got x is equal to 2 plus 3k k जगह रे 0 plus or minus 1 plus or minus 2 plus or minus 3 any integer पढ़ी परिबो because k is an integer given here. So now I can write the equivalence class set here equivalence class of 2. Now I can write the equivalence class of 2 for the relation a congruent to be mod 3 is equal to a set containing these elements k is equal to 0 रे जहाँ पाइलो ताको फर्स्ट लेखो सेंटर रे कारण एपटे माइनस जगह लिखिबा सेपटे प्लस जगह लिखिबा तापर k is equal to 1 रे पाइली 5 ओके देन k is equal to 2 रे पाइली 8 बाकी एमदी पाई की जीबी देन k is equal to -1 रे पाइली -1 सेटा 2 पूर्वर लेख k is equal to 0 रे 2 आस्तिला k is equal to -1 टा तार टिके बिफोर रे लिखिली सेमिति k is equal to -2 अप्लाई कले पाइबी -4 सेटा भी टिके बिफोर रे लिखिली सो दिस इज द equivalence class. if this is the equivalence class for 2 based on the relation 3. So here we explained equivalence class definition and finding equivalence class. Again conclusion is गोटे सेट देछि गोटे इक्विवेलेंस रिलेशन देछि माने सेट रो एवरी एलिमेंट बाय इक्विवेलेंस क्लास फाइंड करि हबो ए रो इक्विवेलेंस क्लास माने सेट ए रो सेही एलिमेंट गुडा को जो माने स्मॉल ए सहित ए रिलेशन ता मेंटेन करि परिबे फॉर एग्जांपल पाई ए रिलेशन ता नेली 2 रो इक्विवेलेंस क्लास फाइंड करिवि 2 रो इक्विवेलेंस क्लास को गुडा को हबो इंटीजर सेट रो सेही एलिमेंट गुडा को जो माने 2 सहित ए रिलेशन ता मेंटेन करिवे लेट्स एलिमेंट गुडा को एक्स नेली जो माने 2 सहित रिलेशन ता मेंटेन करिवे एक्स नेली एक्स को फाइंड कली 3-4 टा वैल्यू फाइंड कली सेमिति लेखि के डॉट 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 दे देबी दैट इज द इक्विवेलेंस क्लास ऑफ 2. Okay, here we have explained the meaning of equivalence class and how to find equivalence class. This is a area from which normally 1 mark question asked find equivalence class. Okay, now pause the video and write the note. In book there is a 4 mark question based on this equivalence class. Okay, now let us discuss it. A 4 mark question based on this equivalence class which normally does not ask in +2 science exam, but I am teaching, you should practice. The question is, prove that A congruent to B mod 3 splits the set of integers in 3 equivalence class. Means what? The set given here Z, the relation given here A congruent to B mod 3, and asking to prove that this relation splits the integer set into 3 equivalence class only. Means this relation को नहीं कि आमे इंटीजर सेट ऊपर जदि इक्विवेलेंस क्लास आसीबो only 3 equivalence class आसीबो not more than 3 equivalence class will come. Okay, so look at, we will find equivalence class of 0 for this relation, 1 for this relation, 2 for this relation. We can find equivalent class of 3 for this relation, equivalent class of 4 for this relation. Okay, jaha mu padhili, the conclusion is we can find equivalence class for 0, 1, 2, 3, 4, any integer. We can find equivalence class for any integer, isn't it? Okay, bujhojna nahi? We can find equivalent class of any integer. So let us find equivalence class of 0. What will be? It is equal to the elements of x such that x related to 0. Means x minus 0 is equal to 3k. This relation divisible by 3. So 0 ro equivalence class रे जदि x गुड़ा को अच्छी, those x will maintain with this relation with 0. So x minus 0 is equal to 3k. This implies x is equal to 3k. This implies x is equal to, in place of k I can apply 0 plus 1 minus 1 plus 2 minus 2. So how to write this set? Put k is equal to 0, x is coming 0, then put k is equal to 1, 3, 2, 6, 3, 9. So putting k is equal to 3 we get 9, putting k is equal to minus 1 we get minus 3, putting k is equal to minus 2 we get minus 6, putting k is equal to minus 3 we get minus 9. Similarly in both sides many elements are there. This is one equivalence class. बुझिपारे बेला माने 0 रो इक्विवेलेंस क्लास फाइंड करिया पे डेली लेट 0 रो इक्विवेलेंस क्लास भीतर थिबा एलिमेंट गुडा को x, then x will maintain the relation with 0. So we are getting x equal to 3k. k जगह रे 0 पुट करि परबी प्लस और माइनस 1 प्लस और माइनस 2 पुट करि परबी. सो एमिति लिखिबी 0 पुट कले जो वैल्यूटा आछि सेंटर रे लिखिबी, 1 2 3 पुट कले जो वैल्यूटा आछि राइट को लिखि जिबी, -1 -2 -3 पुट कले जो वैल्यूटा आछि लेफ्ट को लिखि जिबी. एमिति लॉट ऑफ एलिमेंट्स राइट साइड side रे भी अच्छी, lot of elements left side रे भी अच्छी, that is an infinite set. So 0 रो equivalence class is equal to this set आसिला आगो को भी अच्छी एपटे पछू भी अच्छी. Now let us find 1 रो equivalence class. This is equal to x such that x related to 1. This implies x minus 1 is equal to 3k. This implies x is equal to 3k plus 1. This implies x is equal to again k जगह 0 पुट कले कौन आछी 1 को एठी लिखली, k जगह 2 पुट कले कौन आछी 7 को एठी लिखली, k जगह 3 पुट कले 10 आछी 10 को एठी लिखली. Similarly I can get many other elements. Now putting k is equal to -1 कौन आछी -2 एठी लिखली, putting k is equal to -2 कौन आछी -5 एठी लिखली. Similarly this side भी lot of elements are there, then this set is equal to equivalence class of 1 for this relation. Similarly we can find equivalence class of 2. कौन पाइबी x such that x related to 2. This implies x minus 2 is equal to 3k. This implies x is equal to 3k plus 2. So is equal to again change the set nelly, putting k is equal to 0 we are getting equal to 2, k is equal to 1 we are getting 5, k is equal to 2 we are getting 8 comma dot. Okay, putting k is equal to -1, -3 plus 2 is equal to -1, then putting k is equal to -2, -6 plus 2 is equal to -4 comma dot. Okay, so k is equal to 0 plus or -1 plus or -2 put kale we are getting equivalence class of 2. Now come to equivalence class of 3. X such that x related to 3. This implies x minus 3 is equal to 3k. This implies x is equal to 3k plus 3 is equal to, what is the equivalence class is coming? Putting k is equal to 0 I am getting 3, putting k is equal to 1 I am getting 6, putting k is equal to 2 I am getting 9 dot. Putting k is equal to -1 I am getting 0, putting k is equal to -2 I am getting -3, putting k is equal to -3 I am getting -6. Similarly we can get lot of other elements. Similarly equivalence class of 4 is equal to x such that x related to 4. This implies x minus 4 is equal to 3k. X minus 4 will be divisible by 3. This implies x is equal to 3k plus 4 is equal to, take a set, put k is equal to 0 we are getting 4, put k is equal to 1 we are getting 7, put k is equal to 2 we are getting 10, put k is equal to 3 we are getting 13 dot. Okay, put k is equal to -1 we are getting 1, putting k is equal to -2 we are getting put k is equal to -2 we are getting -6 plus 4 is equal to -2, put k is equal to -3 we are getting -5. Similarly other elements. Okay, look at the equivalence classes we obtained. 0 equivalence class जहाँ आसी 3 रो equivalence class भी से आसिला, क्लियर देखि पारो. 1 रो equivalence class जहाँ आसी 4 equivalence class भी से आसिला. Similarly 2 रो equivalence class जहाँ आसी 5 रो equivalence class यदि बाहर करबी से ही आसीबो. So 0 1 2 रो equivalence class फाइंड कर सरिया परे जहार भी equivalence class फाइंड करिवि सेरा निश्चित भाबे एई तीनटारु कोटा हेले गोटे आसुथुबो. जेमिति 3 रो equivalence class टा 0 सहित आइडेंटिकल हैला, 4 रो equivalence class टा 1 सहित आइडेंटिकल हबो, 6 रो equivalence class टा 2 सहित आइडेंटिकल हबो. समिति तमे 99 पय equivalence class फाइंड करिवो से का सहित ए तीनटारु का सहित भी गोटे आइडेंटिकल हबो. एनी इंटीजर पय equivalence class फाइंड कले से इधर 0 रो क्लास सहित आइडेंटिकल होतुबो बा 1 रो क्लास सहित आइडेंटिकल होतुबो बा 2 रो क्लास सहित आइडेंटिकल होतुबो. आल्सो दिस तीनटा जाको को यूनियन कर देले हमको इंटीजर सेट मिल जिवो. सो हमें कहबा जे दिस रिलेशन डिवाइड्स और splits the integer set into 3 equivalence class only. 3 टाइम equivalence class आसुची ताडू बेसी आसुनी. लोक एट पिला माने एटा बुझाई देली केमिति लेखिबो मु नोट रे देछि. एंड अनदर पॉइंट मन रखो एटा जदी a congruent to b mod 5 हि जिवो देन 5टा equivalence class पॉसिबल हबो. इंटीजर सेट कैन बी स्प्लिटेड इनटू 5 equivalence class. एटा mod 2 कर देले द इंटीजर सेट कैन बी स्प्लिट इनटू 2 equivalence class. Okay, so conclusion is a congruent to be mod 2 thile the integer set will split into 2 equivalence class only. Similarly mod 3 thile it is splits into 3 equivalence class. Mod 5 thile it will split into 5 equivalence class. नोट रे मु दीटा जगह देछि. mod 3 रो केमिति 3 equivalence class आसुची नोट रे लिखिछि. mod 5 पई केमिति 5 equivalence class आसुची नोट रे लिखिछि. दीटा जगह नोट रे लिखिबा very easy, no problem. Now pause the video and write the note. 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 Students, now we discuss a question of elements book related to this equivalence class. Okay, so what is the question? The question is, let R be the relation on the set of real numbers such that A related to B if A minus B is an integer. So look at what is the telling in the question. Question is a relation small r on real number set given as A related to B means A minus B is an integer. Okay. So in question given relation small r on capital R which is the real number set, and the relation is defined as A related to B implies A minus B is an integer. It is asked to test this relation for equivalence and find the equivalence class of 1.5. We have to test this relation for equivalence and also find the equivalence class of 1.5. So look at, let us discuss the first part, testing for equivalence. Let first testing for reflexivity. Okay, so what we have to do? We have to see that A related to A is true or false. A related to B is given by A minus B is an integer. So if A maintain that relation with itself, then it is reflexive. Means if A related to A is true, reflexive, A related to A is false, not reflexive. So how we can know that? A related to A implies A minus B, A related to B implies A minus B. So A related to A implies A minus A is equal to 0. 0 is an integer or not? So the relation given is A related to B such that A minus B is an integer. We got A related to A is equal to 0, which is an integer. So A related to A is true or false? Clearly true. Any element A निज सहित relation टाको obey करुछि. A B सहित जदि relation obey करिवो, A minus B गोटे integer हेले ही आमे कहि परिबा A B सहित relation obey कला. Now A निज सहित भी से relation टा obey करि परिबो कारण A minus A is equal to 0 is an integer. So we can say that any element can maintain that relation with itself. So the relation is reflexive. Testing for symmetricity. We have to take A related to B and we have to find B related to A. This is given. With help of this, if we can obtain this, then we can say the relation is symmetric. here relation is represented by small r. आ पूर्वरु सब जगह हम relation को capital R देखौथिले, but here relation को small r देखाई छी because set real number set टा capital R देछि. So to prove symmetricity we have to take A related to B and we try to obtain B related to A. If we can obtain, then it is symmetric, otherwise it is not symmetric. Now A related to B implies A minus B is equal to K, where K belongs to integer. Because A related to B is given, A minus B is an integer, so I have written A minus B is equal to K, where K belongs to an integer. Now this implies B minus A is equal to minus K. Now if K is an integer, minus K is also an integer. So B A सहित से relation टा maintain करि पारला नहीं, clearly करि परिबो. A जदि B सहित relation maintain करिवो, A minus B integer हेले. Similarly B A सहित relation maintain करिवो, B minus A integer हेले. Here we got B minus A is equal to an integer. Now as B minus A is equal to an integer, so we can write B related to A is true. So we have taken A related to B and we got B related to A is true. So this is symmetricity. Now let us test for transitivity. So when it will be transitive? If A related to B and B related to C. If A related to B and B related to C implies A related to C, then it is transitive. Means these two are given. With help of this, we try to get this. If we get A related to C, then it is transitive. If you don't get A related to C, then it is not transitive. Okay, this implies A related to B and B related to C. A related to B implies A minus B is an integer, let K1. Similarly, B related to C implies B minus C is equal to K2. Both K1, K2 are integer. This implies adding these two, I get A minus B plus B minus C is equal to K1 plus K2. This implies A minus C is equal to K1 plus K2. Now if K1 is an integer and K2 is an integer, so K1 plus K2 is surely an integer. So A minus C is equal to an integer, means I can write A related to C. Given A related to B means A minus B is an integer. We got A minus C is an integer, so we can write A related to C. So by taking A related to B and B related to C, we got A related to C. So clearly the relation is transitive. Also clearly the relation is equivalence. Now in this relation, we have to find equivalence class of 1. Equivalence class of 1. This is equal to a set containing elements X such that X related to 1 and X belongs to Z. ठीक है माने पकाओ equivalence class कथा ठीक just पूर्वरु पढ़ेली. So equivalence class of 1 is equal to a set containing elements X such that X related to 1 and X belongs to Z. So this is equal to, this implies X related to 1 means X minus 1 is equal to an integer K, where K is an integer. This implies X is equal to K plus 1. So K जगह में कौन put करी परिबा? Complete integers put करी परिबा. If K जगह में complete integers put करी परिबा, so X is equal to कौन आसीबो? It is also an integer आसीबो. So this implies X is also an integer set. So equivalence class of 1 is equal to हमें कौन लिखिबा? Integer set, or I can write Z plus 1. Because K जगह any integer put करी परिबा, so this को हमें shortcut लिख दे परिबा Z plus 1. Now let us find equivalence class of half. equivalence class of half. Equivalence class of half is equal to set containing elements x such that x related to half. This implies x minus half is equal to an integer, because a related to b implies a minus b is an integer. So x related to half means x minus half is equal to an integer. This implies x is equal to k plus half. K जगह any integer पकई परिबा, so I can tell this as z plus half. So equivalence class of half is coming z plus half. Z जगह any integer पकई दे परिबा, and equivalence class of 1 is coming z plus 1. Z जगह में any integer put करी परिबा. This is a question from Elements book. Note देइछि केमिति लिखिबो एठी just बुझी देली. Okay. Now, so look at to the question, students. 1 mark question. Find least positive integer r such that 185 belongs to equivalence class of r. Here is 7. So what does it mean? This means the relation is congruent modulo 7. A congruent to be modulo 7. And r least positive value kete hele, this relation pai r equivalence class re 185 rahuchi. So if r equivalence class re 185 rahuchi, 185 r sahita relation ta maintain karibo. Relation ta kono? Congruence modulo 7. So 185 minus r is equal to 7 k haba na. क्वेश्चन रे कहूची r लोएस्ट वैल्यू केते हेले 185 टा r इक्विवेलेंस क्लास भितरे रहिबो विथ दिस रिलेशन. सो r इक्विवेलेंस क्लास भितरे जदी 185 रहूची 185 टा r सहित से रिलेशन टा मेंटेन करि परिबो. रिलेशन टा कांग्रुएंस मॉड्यूलो 7 देची. सो 185 माइनस r इज इक्वल टू 7 के हबरा ने. अब दिस इंप्लाइज r इज इक्वल टू 185 माइनस 7 के. ओके, r रो लोएस्ट वैल्यू पचारछि. r रो लोएस्ट वैल्यू आसीबा पई k हाईएस्ट हेबा दरकार. r रो लोएस्ट वैल्यू आसीबा पई k हाईएस्ट हेबा दरकार. सो k रो हाईएस्ट वैल्यू केते हबो जानिबा पई 185 को 7 रे डिवाइड करबी. 7 रे डिवाइड करले 7 2 सा 14, 4 बढ़िला 45, 7 6 सा 42 एकी रिमेनिंग हला 3. सो r लोएस्ट वैल्यू पाइबा पई k रो हाईएस्ट वैल्यू पुट करबा दरकार. k जगह हाईएस्ट केते पुट करि परबी 26, कारण k जगह 26 पुट कले रिमेनिंग होची 3, तनो r जगह 3 आसीबो. इफ k जगह 27 पुट कर देबी ए पार्टटा नेगेटिव हबो ना नहीं, कारण k जगह 26 पुट कले जदी एतिकी जिगुड 3 आछी, k जगह जदी 27 पुट कर देबी 7 into 27 एक निश्चित भाव एटा नेगेटिव हे परिबो. क्वेश्चन रे कहिछि r टा लोएस्ट पॉजिटिव, तो r को लोएस्ट पॉजिटिव को रखिया पे k मैक्सिमम केते पुट करि परबी 26. बुझ पालो. k जगह जदी 27 पुट करि निजे चेक करो एटा नेगेटिव आस जिवो. सो k जगह 27 रे नेगेटिव आछी, 26 रे r टा पॉजिटिव आछी. k इज इक्वल टू 27 पुट कले r टा नेगेटिव आछी, k इज इक्वल टू 26 पुट कले r टा पॉजिटिव आछी. सो k जगह मैक्सिमम केते पुट करि परबे 26. सो k जगह हाईएस्ट 26 पुट करि परबे माने r लोएस्ट वैल्यू केते हबो 3, कारण रिमेनिंग आसला जो 3 से r लोएस्ट वैल्यू 3 हबो. k जगह जदी 26 पुट करबी जदी कि कोन हो 3, सो r लोएस्ट वैल्यू केते हला 3. बुझलो. 1 मार्क क्वेश्चन कहूची 185 बिलोंग्स टू इक्विवेलेंस क्लास ऑफ r विथ रिलेशन 7. सो एटा म लिखि परली एज पर डेफिनेशन ऑफ इक्विवेलेंस क्लास. एटा जेहेतु r लोएस्ट पचारिची k मैक्सिमम केते लिखि परिबी फाइंड करबी, सेडा फाइंड करिया पे डिवाइड कर देबी, जहा आसिला मैक्सिमम सेति की पगई परिबी, एंड रिमेनिंग टा निश्चित भाबे r रो वैल्यू हे परिबो. माने रखो r पॉजिटिव हेबा दरकार. एबे जोड़ा वेरी इंपोर्टेंट क्वेश्चन 1 मार्क बोर्ड परीक्षा में एलिमेंट्स बुक पे सिमिलरली 2-3 क्वेश्चंस आर देयर. सो स्टूडेंट्स, with this the relation chapter for CHSE board exam level is completed. Now what you have to do, you have to watch the video repeatedly, remember the concept, practice the questions what I have taught, then go to the exercise of elements book. Try every questions of elements book. जदि किसी न हो पारिकी रहीगला डाउट क्लियर क्लास रे मु समस्तंकर गोटी गोटी डाउट क्लियर करी निश्चित भाव सब क्वेश्चन ट्राई कर आ वीडियो को लाइक मार चैनल को सब्सक्राइब कर और वीडियो कोचिंग को एंजॉय कर नाउ पॉज द वीडियो एंड राइट द नोट नाउ पॉज द वीडियो एंड राइट द नोट नाउ pause the video and write the note.